Hi class, these examples go with your 3.3 vocabulary. This section is for the converse of those different angle pairs we learned about in section 3.2. So we've got 4 different angle pairs we were looking at, corresponding angles, alternate interior, alternate exterior, and same side interior. So we noticed that if you had parallel lines cut by a transversal, then those angle pairs had certain relationships. Here, we're basically doing the opposite. We're saying if those relationships exist, then the lines have to be parallel. So I'm just going to write on the top here some of those different angle pairs. So if I have corresponding angles that happen to be congruent, if that is the case, then the lines are parallel. Okay? If I have alternate interior angles, and if they are congruent, then the lines have to be parallel. Alternate exterior, if those are congruent, my lines have to also be parallel. And the last one, this one's our one that's a little bit different, but same side interior angles. If they are supplementary, I'll put 180 degrees for short here, then my lines will have to be parallel. So we're looking for these angle relationships, and if they exist, the lines have to be parallel. Okay, so in example number 1, I'm told that angle 2 and angle 3 are supplementary. Well, those are same side interior angles, right? So if I'm doing my proof, start with my given. So angle 2 and angle 3 are supplementary. That's given. Well, if that relationship exists, the lines have to be parallel. So R has to be parallel to S. And the reason is this is the converse of the same side interior angle theorem. And that's it. Nice, short, and sweet. Okay, moving on to example 2. Given 1 and 4 are supplementary, prove that R is parallel to S. I'm told 1 and 4 are supplementary. I want to show that those lines are parallel. So I need to look for or show one of these 4 relationships exists. So 1 and 4 in my picture are none of these. So it's not going to be quite as nice as that first proof. But if I can make a connection here between one of those angle pairs, I should be able to make this work. So we'll start with my given. 1 and 4 are supplementary. Okay, and where I always like to go with this is what does it mean to be supplementary? So use that given to keep going. So I know that being supplementary means that their measurements have to add up to 180 because that's what it means. That's the definition of supplementary angles. Okay, so I'm going to zoom in just a little bit more for you guys. Okay, all right, well, let's see if I can make some sort of a connection here. So 1 and 4 together are 180 degrees, right? Well, I have some other pairs that are also 180 degrees. Angle 4 and 3 because they're a linear pair, and angle 1 and angle 2 also because they're a linear pair. So let's see. If I can say that angle 4 and angle 3 also equal 180, then that's from the linear pair theorem. So here I have something kind of cool going on. So I have this equation equals 180, and this equation equals 180. So since they both equal 180, these equations also have to be equal to each other. So that's where I kind of have those 3 parts, and I'm saying that they're equal. So I've got the measure of angle 1 plus the measure of angle 4 has to equal the measure of angle 3 plus the measure of angle 4. So I have kind of those 3 parts, 180, and then I've got these 2 equations. Anytime I have 3 parts that are all kind of equal to each other, that's that transitive property. Okay, so now, notice I've got angle 4 on both sides. I could get rid of that if I subtract it off using the subtraction property of equality. So then I've got the measure of angle 1 equals the measure of angle 3, right, when I simplify. So if I could show angles are, what kind of angles are 1 and 3? Oh, those happen to be corresponding, right? If I show corresponding angles are congruent, I've shown that R is parallel to S. So I want to jump back into that congruent language. So I'm going to say that since their measurements are equal, they are congruent. So that's just the definition of congruent, right? And in our case specifically, congruent angles. So if their measurements are equal, then they're congruent. And because 1 and 3 are corresponding, R is parallel to S by the converse of corresponding angles. All right, awesome. Okay, we've got one last one here where we're going to use the converse as well. So in this one, I'm given measure of angle 8 and measure of angle 4. Those are alternate exterior angles. So if I can show that those are equal, then I can prove that R is parallel to S. Okay, so that's my goal. Show that those are congruent. All right, so let's start with some givens. Measure of angle 8 equals 3x plus 13. Measure of angle 4 equals 5x minus 5, and x equals 9. Those are all given. Okay? Oh. So now I should be able to just plug in 9 into each of these, right? And if I can show that those are the same, then I'm on the right track. So I'm going to go ahead and plug in 9. So I'm going to do angle 8 here first. So I'm just using substitution when I'm doing that. And then I can simplify to show that angle 8 equals 27 plus 13, which is 40 degrees. Okay, and I'm going to do the same thing for angle 4. So I'm going to take that angle 4 and substitute in 9. So we've got the measure of angle 4 equals 45 minus 5, which is also 40 degrees. So if measure of angle 8 equals 40 and measure of angle 4 equals 40, then I can say that the measure of angle 8 equals the measure of angle 4, right? If they both equal 40, then they're equal to each other. So that's, again, that transitive property, those three components. Okay, so now, again, I want to go from using equals to congruent to be able to show that those lines are parallel. So if their measurements are equal, then they are congruent by the definition of congruent. So angle 8 and angle 4 are alternate interior. So since alternate interior angles are congruent, these lines have to be parallel. So we use the converse of alternate interior angles theorem. Okay, so there's that last line there for you. So R has to be parallel to S by the converse of the alternate exterior angles theorem. Alright guys, so you'll be using those converses to help you on your 3.3 homework. Hopefully those couple examples will help you. Thanks for watching.